Well, good evening, everybody. My name is Brian McCullough. I'm the meeting chair for the Royal Astronomical Society, the Ottawa Centre. I'm sorry I missed last month. I was away to Calgary. I skipped out just ahead of the snowstorm. Is that the snowstorm one? Yeah.
Yes.
I skipped out of town just ahead of that. We've got a full program this evening, so I'm glad to see so many people down here. This looks awfully quiet.
Mm-hmm.
Why is this so quiet? I'm hearing
What's wrong
boom.
with our sound system?
Oh no.
And it really matters.
Okay, well, we'll get that sorted out in a minute then. All right. So cell phones off, pagers off. Mine is now on stun. Tim, I think we're a little bit high, maybe on the mic level. Thank you. All right. So the Chris Tarrant, of course, working the controls here for us as every meeting, so that makes things work out as best as they would ever come out, better than I would do, let me tell you. All right, we'll go to the next one, please. Here's the program for this evening. All right, pretty good program we've got on. Weldon, Hannaford on cosmic rays, Richard Alexandrowich, biology in space, and true turtle stories, or not. All right, we've got our break with the door prizes. Got a nice set of prizes here tonight. John Thompson on the long-awaited Solar Cycle 24. All right, where is it? Solar Cycle 24, where are you? Rolf Meier on the Mars opposition, and we've got some observations and observing challenges as per usual. So we've got a couple of announcements to start with. If we can go to the first one. Sorry, Rolf. April 27th, 1978. Rolf Meier is sitting right in the middle row back there, made the first discovery of a comet from Canadian soil, from a Canadian observing site. So that's 30 years ago this month. So well done on that, Rolf. That's the copy of the International Astronomical Union circular that was published to announce that. Rolf went on, that was in 1978. He also discovered comets in 1979, 1980, and 1984, I think was the last one. So what have you been doing since then? Oh, Mars stuff. That's right. Okay, so anyway, Rolf, congratulations on that. All right. Okay, now, do we have sound hooked up?
We will find out.
Now, again, we have been supplied with a disc, a DVD from the Toronto Centre, because this summer, the July 1st weekend, is the General Assembly of the Royal Astronomical Society of Canada, being held in Toronto this year. And they sent us this DVD. And do you think you have turn down just. And against my better judgment, we're showing it. I think ours was much better in 2006, but here you go. Is that too loud?
Yes.
Okay. Okay. Yeah, I know. Should we get a wave going or something?
No.
Has anybody found the point of this yet?
A long time ago in an RASC center far away. Oh dear. Oh dear. Talk about typing. Celebrator said too back in the
Yeah. Hasn't this thing run out of tape yet?
You can get 8 gigabyte on a DVD, but that doesn't mean you can use it all.
Oh, that's gonna be enough. Oh, all right. Yes, a smattering of applause. I'll report back to Toronto on that one. So the short line on that is the General Assembly is being held this summer, midsummer at Toronto. Early bird registration ends the end of April. Go to the RASC national website, rasc.ca, and get the link to the 2008 GA, and you're good to go. One of the news notes of recent, item by Tom Spears in the Ottawa Citizen. This is concerning Gary Boyle, who's been doing some live astrocasting from his Orion's Belt Observatory. And this has been very interesting. So Tom Spears had a little item in the on the online edition of the Citizen. So I've asked Gary if he can come up and give us a little update on what it is that he's doing with his astrocasting. Gary?
Oh, yeah, thank you, Brian. Well, as amateur astronomers, there's a few ways to actually look at the sky. It's either observe by yourself in the quiet of night, observe with others, and discuss astronomy, or really share your observations with the world. Next slide, please. So here we have it set up in my observatory. As Brian said, Orion's Belt Observatory. I have a 12-inch Meade LX200, and with the Mallancam Pro video camera, which Rock is here in the audience. Rock, say hi. and just an outstanding tool to really has helped revolutionizing astronomy for sure. Okay, next slide, please. So as always, we're trying to see, these faint images from the city, you really have to get out to the country. But we live in the age now of CCD chips and circuit boards and, of course, the internet. And for the last couple of weeks, I've been actually astrocasting, which I call it astrocasting, over the internet. And it's quite easy. Next slide. So on my website, wondersofastronomy.com, you'll see over here there are 2 links. I actually have 2 channels, one on Yahoo Live and also on Ustream.tv. But I tend to use the Yahoo. In 6 nights, I've only broadcasted for a total of about 12 hours. I've had up to now 1,460 hits, and that's around the world, all across the North America, right down to Santiago, Chile, even to New Zealand. And you can actually chat online too. There's a little online chat, which we'll see in a second. And through Yahoo and Ustream, you just sign up with a password and it's free. Next slide. So here's actually a screenshot of what you'll see if I am broadcasting. You'll see an actual live image, which I'll show you. And here again, you can sign in and we just chat around the world, ask for objects. And it's great because now we have the younger generation that are surfing the web, searching the internet for any kind of site. And so many times people have got on and said, wow, man, this is cool. Like they've never seen a galaxy. Like, what is that? And explain what it is. So with this kind of revolutionary broadcasting over the net, we can attract, not for us, but just astronomy-wise, introduce the youth to astronomy, actual true science. Next slide, please. And this is just through Ustream, the other channel. Sometimes Yahoo is a little quirky. It's in the beta version, so sometimes it does time out. And if I do have an issue, which with my modem, but sometimes with Yahoo, I'll switch over to Ustream. But I'll put a message on there. Has anyone ever been on my, seen mine yet? No? Okay, excellent, good. Okay, next slide. So here's just some screenshots of what we can see. Of course, here's Saturn. See some good detail. Okay, next. Then we're in a globular cluster. And these are live images. Because the great thing about the Mellencam is that it can stack up to 128 images inside the camera and refresh every 2 seconds. On my version, every 2 seconds. But the more recent can go up to 14 and 28 seconds and even has color now. So, but still, it's just true astronomy. Next slide, please. And here it is, M82 from southern part of Ottawa. And rock even from downtown Ottawa can get even better with the better camera. So if you don't have chance to observe outside, and it's great for you around the world too, say if there is a double or triple transit of Jupiter, people around the world can see this via my telescope. Or there are a few scopes around the world which are doing this too. So really it's not just a local thing, but it's a global issue. And next slide. And quickly, just here's my control room. It's insulated, stays warm, stays about 15 degrees warmer than the outside temperature. And that's really because this guy cranks out a lot of heat. And really, this guy is hooked up to the telescope with the Sky software and the laptop, which has a wireless connection. Of course, the stereo just for atmosphere. If you're in there about 3 or 4 or 5, 6 hours, it's nice to listen to some music every now and then. So that's what I'm doing. I invite everyone to, if you can, check out my links. As I said, the Yahoo on clear nights, mostly on the weekends, sometimes during the week, but we do have personal lives too. About an hour after sunset, so now it'll be tomorrow night, hopefully if the weather clears, by about 8:30 till 2 or 3 o'clock in the morning. Get on, chat, say hi, and hope you have a good time. So I'll be around for further questions later because we are quite a short on time.
Gary, who's the astronaut in the photo there?
Oh,
I shouldn't have asked. Okay, it's a mystery.
Irvin.
Hey?
Irvin, I think.
Oh, okay. Oh, Jim Irwin from Apollo
Yes,
15?
I think so. Yes, I think.
It kind of looks like that hairdo. Yeah. Okay.
Yep.
All
Okay,
right.
so I'll see you later, folks. Hopefully everybody tunes in tomorrow and get those stats up.
Well done,
Thanks
Gary.
a lot.
Thank you.
Thank you.
First of all, you probably noticed Eric here is videotaping our meetings. Last month, of course, we were almost snowed out, but some of us showed up. The video DVD of last month's meeting, excellent presentations about Mercury, etc., will be available in the library. So you can see last month's meeting. Thanks a lot, Eric. Okay, a couple of announcements first. First date. Get it on there. Saturday, the 10th of May is International Astronomy Day here at the SciTech Museum. Volunteers are needed for displays, telescopes, day and evening. I will be here all day as well, so anybody that would help out, just let me know, email or tonight personally. And the second one, excuse me, rundown got me out of breath. June 13th, 14th. Now this one starts at 11 p.m. It's the Relay for Life for Cancer Research. It's an all-night event, and the RASC participation is requested. So again, talk to me or email me if you can participate in any way. Okay, first of all, next I guess, I have started up a monthly trivia question. So the rule is I'll end with the question. During the break, if you know the answer, let me know. And the correct answer will get a, tonight the prize is a shatter cone from the Presqu'île impact structure, a guaranteed official shatter cone. So the trivial question is coming up, but first of all, this month we observed the passing of Arthur C. Clarke, one of my favorite scientific and science fiction writers. And here he is at the scene of the 2001 movie setting. Next one, please. Of course, he wrote the book, 2001, and it was in 2001 in the book, he went to Saturn, not Jupiter, like in the movie. Now, Jean-Dominique Cassini first discovered the moon that they went to in 2001, Iapetus. He discovered it in 1671 and noted immediately that Iapetus was far fainter and harder to see on one side of its orbit than on the other. So, of course, Arthur C. Clarke used this as the base for his story of 2001, and he had planted a alien structure on that moon, which caused it to be brighter and darker on the other side. Next one, please. So here's Iapetus from the Cassini probe. Now, unfortunately, there's no alien structures on there, but we can see the bright and darkness of it, and of course that mountain in the middle, that's still unknown why that's there. But anyway, I'm just going to read a couple of paragraphs from the story 2001 because I was just fascinated by the book. I don't know if you've all read the book, most of us. Well, I'll just repeat here what really, really excited me. So here's astronaut Bowman just skirting over the surface of the Iapetus, looking for this structure. And he's reporting back to Earth via the spacecraft by relay. I'm only 3 miles away now, holding altitude at 4,000 feet. Still not a sign of activity. Nothing on any of my instruments. The faces seem absolutely smooth and polished. Surely you'd expect some meteorite damage after all this time. And there's no debris. I suppose one could call it the roof. No sign of any opening either. I've been hoping there might be some way in. Just a minute. That's odd. Long pause. Okay, if you want to know what happened, you have to read the book. Anyway, next slide. So, my question is, what connection does Earth, our planet that we're standing on right now, have with Iapetus? Talk to me at the break. The winner gets a shatter cone.
Okay, folks, it's a relatively slim month, which is just as well because we all have to do our income tax returns. Yes, and then after that, we'll all hang ourselves with our, and never mind, forget it. Anyway, yes, we would have had a double shadow transit, except for a nasty little problem that the double shadow transit starts before Jupiter rises, which makes observing it somewhat problematic. However, by the time it's risen at a comfortable level, this actually looks like it's actually going to be kind of fun. You're going to get a bit of an eye-out transit, which isn't terribly rare, of course, but that nice big shadow should be good. There's actually a little bit of a shadow there at the very end of it as well. You can see right by the right-hand limb. So anyway, all good fun. The other thing that might be interesting is, guaranteed, of course, we're not going to be able to see it, but it might be a good opportunity to catch the Great Red Spot plus Little Red plus Littler Red, or whatever they're going to call the third one. However, it's axiomatic that whenever you want to try to find it, it's on the other side of the planet. I think the planet actually speeds up slightly when it detects an observer. It's the only thing I can figure. One of these quantum mechanics things, I guess. Anyway, Moving right along, he said subtly. So there's the little bits. Ooh, yeah, all I needed was a little mouth under that. We'd be just fine. Forget a face on Mars. We get a face on Jupiter. Anyway, never mind. Forget it. So there you go. That's the good stuff to look at, I hope. Moon occults the Pleiades. Yeah, yippee-doo. We always have this moon occulting something, except I really enjoy the moon occulting the Pleiades, and this is my second favorite occultation mode, where the dark limb is sailing in. I really love it when it's the illuminated limb sailing in, because then you get stars just popping out of the other side, and it's a real headbanger. However, this works pretty well if you can go and click on the appropriate spot on there. I rolled in a little movie.
Where?
Click anywhere. Click the, well, actually over the moon, over the moon. You see the little finger there? Give it the finger. Click the button, Igor. All right, imagine, if you will, the moon gently moving past the Merope Nebula down there. Well, you don't have to imagine. You can go see it. Well, actually, probably not, because it'll be cloudy. But at any rate, moving right along. Actually, Gary could show it to us. If it's live, that'd actually be a good one for you. And it's not a bad time of day either. Okay, I just put the kibosh on it. It's guaranteed going to be cloudy. If you can move on for me. Yes, we have the Lyrid meteor shower, one of the most boring meteor showers of the year. We can see we have 20 whole meteors per hour and a nearly full moon. So if you get to see a meteor, please report it immediately, and we will check to see whether cosmic rays are impacting your eyes. However, there ain't a whole hell of a lot this month, so hey, take what we can get. Seriously speaking, though, I mean, there are regular meteor showers, and they're written up in the Observer's Handbook, and it is an opportunity for people who've never seen meteors to see them. Now, in here, that maybe doesn't apply, but if you have friends who are not astronomically inclined, you'll discover that many of them say they've never seen a shooting star. I will go out and see half a dozen. My wife won't notice one, and she's got better eyesight. She just doesn't notice them. So the meteor showers are a great opportunity to get your astronomically challenged friends an opportunity to see something. So it's not a bad thought, even for those of us who for whom it's old hat. So it really is something nice for sharing the sky. Okay, guys, that's about it, and I will do you all a favor and leave.
All right, thanks, Tim.
Okay, now, this machine. Ready? Go. In the year 1912, an Austrian scientist named Victor Hess went up in a balloon with 3 ion detector instruments on board. His purpose was to prove that the Earth was a source of ions seeping up out of the ground, and of course they should diminish as he rose higher and higher. But instead, he discovered that the ionization rate was increasing as he went up. And when he got to the top of his climb, 17,000 feet, the rate of ionization was 4 times greater than he had measured back on the ground. And so Victor Hess had just discovered cosmic rays. And for that discovery, he received a Nobel Prize. Unfortunately, the newly discovered phenomena acquired the name cosmic rays before its real nature was discovered, and the name cosmic rays stuck. However, they're not rays, not like X-rays or rays of sunshine. Cosmic ray is a stream of particles, mostly protons, but wait till I get this fixed here. Also nuclei of hydrogen, helium, including neutrons, of course, very rarely even some heavier nuclei. Furthermore, the cosmic rays we detect here on the surface of planet Earth are a byproduct classified as secondary particles. They originate when the primary particles were from somewhere out there in outer space, when they collide with ions and molecules up in the atmosphere, and they trigger a cascade of secondary particles. that are called cosmic ray shower. The primary particles impart their energy to the secondaries, and they continue in much the same direction as the primaries, and with their share of the primary's energy. Now, cosmic ray showers come in a wide range of energy. The frequency of occurrence diminishes rapidly as the energy increases. Those in the highest range of energy occur only about 1 particle per square kilometer per year, and at the bottom end of the energy scale, the rate can be as high as 10,000 per square meter per minute. Okay. In this business, energy is not measured in joules or ergs. It's measured in electron volts. An electron volt is the energy acquired by an electron in traveling through 1 volt, a gradient of 1 volt. The highest cosmic ray energies are up in the 10 to the 20th electron volts. That's 100, no, that's wrong. That should be 10 to the 18th. No, that's right. That's 100 billion electron volts. A whopping pack of energy for those tiny little particles. And it's 100 million times the greater than the energy that any man-made particle accelerator can ever achieve. And whereas the source of cosmic rays with energies below, say, 10 to the 18th volt, billion that is well known, such as supernova in our galaxy or the sun, especially during sunspot activity, the source of the ultra-high energy cosmic ray showers has until very recently been a complete mystery. Although it has been the subject of much speculation and conjecture. And for example, to quote from one article, such energies are so extreme that they could arise only in the most violent places in the universe. Quite so. But there has been no valid proof until now. And that brings me to the main point in giving this talk. Oh, in just a second. Yeah, sure, anytime. Number 1. The task of collecting a useful quantity of extremely rare, ultra-high energy cosmic ray particles within a workable time requires a very, very large array. There are, or there has been, as many as 4 such arrays in the world. The Pierre Auger array in Argentina is by far the largest and best equipped. A consortium of 330 scientists and 32 organizations has recently built and put into operation in January 2004 the Cosmic Ray Observatory, named after Pierre Auger, a pioneer in the study of cosmic rays. Okay, Chris, you got it? Is it here? Oh, there it is. Okay. An array of 1,600 cosmic ray detectors on the ground covers an area of 30,000 square kilometers. Each detector has a large tank of water in which the particles are captured, and the water is treated chemically to cause the particles to emit a kind of radiation called Cherenkov radiation, which provides a measure of the number of particles and their energy. And around the perimeter of the array, there's 24 telescopes pointing inwards. And Next page. They observe and measure the streaks of fluorescent light. Uh-oh. You guess the next one.
Where?
Yeah, there it is. Generated by a cosmic ray shower at night. The information from 2 or more telescopes will reveal the azimuth and slope of the incoming particles, and the intensity of fluorescence will provide a measure of the energy, as well as will the Cherenkov radiation in the tanks. The detecting tanks on the surface and the fluorescent detecting scopes are complementary, and they provide cross-checks and redundancy in the measurement of cosmic ray shower parameters. The report given in Science magazine last November 9th tells of the Auger array collecting 1 million cosmic ray events since January 2004. Of that million, only 80 had energies over 40 exa-electron volts, and an exa-electron volt is 10 to the 18th electron volts. That's a billion. Only 27 of those showers had energies more than 57 exa-electron volts. And of those 27 events, 12 were found to originate within 30 degrees of, and I quote here, 30 degrees of active galactic nuclei, or AGNs. By my own count, there were another 10 events that were within 4 degrees of these AGNs, or as they're better known, black holes or quasars. Now, I must explain, active galactic nuclei, or AGNs, are galaxies with central black holes. There's a catalog with a list of all the known active galactic nuclei compiled by Veron Seti and Veron and published by Astronomy and Astrophysics. The 12th edition of the catalog contains 694 active galaxies at distances smaller than 300 million light years. At greater distances, the catalog is increasingly incomplete, but that's irrelevant here. This diagram shows how well their calculated sources coincide with the AGNs that are listed in the catalog. Is this the...
Do you want to change the slide?
I need, oh, here it is, okay.
It's just that top button.
Yeah,
Okay.
okay. Now,
Next.
next,
There it is there, Weldon.
yeah, oh, yeah, there, whoops, caught here. Okay, well, yeah, here's a group, each ring here is the position that was calculated from the observed, and then...
I'll just hold the microphone for you. What?
Oh, sorry.
Does that?
Yeah, and all of these little asterisks, they're supposed to be red, but anyway,
Tim, you got that handheld up? Okay.
each of these little asterisks is one of the AGNs, or black holes, in the catalog. And of course, the thing to see is how they coincide with these rings that are the calculated positions. Well, there's 1, 2, 3, 4 calculated positions. This one here has 4 or 5 AGNs right around the perimeter. This one has 1 AGN where the 2 rings overlap. There's 3 coincidences here. This one here has DTNs coinciding with that.
We'll just check the microphone there, Weldon. Sorry to interrupt. There it is.
I'll have to get that fairly close to your.
Hold it a little bit closer to your mouth.
Okay. Everybody hear me?
Okay.
Perfect for karaoke.
The most impressive results are right along this nice big cluster along here. There are, I forget, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's about 15 catalog positions, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 calculated positions there. There's more bullseyes right here. There's one calculated position with a quasar right smack in the middle. This group over here also has a nice coincidence.
All right. You gonna stay on this mic now?
Yeah,
Okay.
I think so.
Perfect.
Oh, yeah. Now, in the middle of this cluster I was talking about.
Can you do it from this mic? Stand?
Yeah, I think so. In the middle of this cluster here, I don't know if you can see it from back there, there's a white dot. Yeah?
Yeah.
Good. Okay, that marks the location of the galaxy Centaurus A with a capital A. And it's the only galaxy or quasar or black hole that's even identified in anywhere in this article that appeared in Science. Yeah. Okay, now the galaxy Centaurus A is in the Centaurus constellation, of course, which is in the southern celestial hemisphere. So what's it doing there in the northern hemisphere? Well, you might well ask. The explanation is that figure 2, this figure here, is not in our conventional astro coordinates, RA and declination. It's in galactic coordinates, where the galactic equator is in parallel with the central plane of the Milky Way. Therefore, the galactic poles are tilted and displaced 63 degrees from our geographic north and south poles. So, in order to put Centaurus A in a more familiar setting, we can switch to the next one now. I took this, yeah, there we are. I got this map from our observer's handbook, All Sky Map. It's the May All Sky Map. And I also got the position of Centaurus A from another page on the, whoops.
You might want to just stay by the microphone.
Yeah.
It might be easier.
Yeah.
Yeah, I got these wires in the way.
Anyway, so, whoops, we're pushing the wrong button. Centaurus A, can you see the little dot there?
Yeah.
I plotted it on this All Sky Map from the handbook. There's where Centaurus is, right there. And that cluster that it's in, whoops, something's gone wrong. That cluster that it's in just goes down this way, and the other smaller cluster is up in this direction here. So, and there's the equator. So you can see Centaurus A is well to the south, and we'll never see it here in Ottawa. However, the Auger Consortium, the people that are running the observatory here, they're planning to set up another cosmic ray observatory, even larger than the one in Argentina, somewhere in the northern hemisphere, possibly in Colorado. And together with Argentina, they should have complete coverage of the sky. Now, I have two pictures of Centaurus A.
There we go.
Ah, there it is, the whole thing. And the center is certainly shrouded in hell and brimstone. And now we can have a closer look at this. There we are looking right at the nucleus. Well, the nucleus is a black hole that's buried deep under all of that violent activity. Anyway, it certainly looks like a violent environment, and down deep in there is a black hole that sucks in everything that comes within, well, it gets too close. And so makes you wonder, how come it then is it ejecting small particles, atomic particles? Isn't that typical of astronomical research? Every mystery that's solved just reveals another mystery. There's just one other item I should mention, and it involves the Big Bang and the residual cosmic microwave background. Three physicists named Grayson, Zatspin, and Kuzman theorized that ultra-high energy cosmic rays would interact with the weak 2.7 degree Kelvin cosmic microwave background, and they'd lose their significant energy if they had to travel beyond 600 million light years. And this is known as the GZK effect. GZK is the initials of the three authors of the theory. The Science article says that the data on the highest energy cosmic rays confirms this GZK theory. But the article does an obscure job of explaining how. I think their observations show a rather abrupt cutoff in energy among the showers that don't coincide with anything. And that, folks, is the end.
Great. Thank you, Willie.
Oh, by the way, I have made a few copies of the article that appeared in Science magazine back last November. So if you're interested, just come see me. You can have a copy.
Sweet. That's great. Thank you, Willie. All right, thanks, Willie. All right, up next, Richard. Richard Alexandrowich on biospace.
You've got 5 minutes.
Good evening, everyone. Anyone want more snow? No, I share. I think today's the last day. Okay. I'm sure a lot of people have contemplated in the past, especially when you're out alone out in the field, whether we're alone or not alone in this small Earth of ours, whether there's other life, primitive or advanced, and its existence in other parts of the galaxy, or for that matter, in the entire universe. Now, sometimes you, on a dark stretch of road, you've wondered whether someone is staring back at you from a sea of suns, and wonder if someone is actually looking back at you or not. And right now, we're looking back at them for the time being. and knowing that other living sentient beings in the world would have a profound effect upon humanity, socially, culturally, and even psychologically. Well, historically, next please. It was like we can compare it analytically to Christopher Columbus discovering a new race of peoples across the vast and mysterious ocean. Only this time it would be across the immense vastness of space, and of course the jump would be much, much bigger. And it would forever change the heartbeat of our planet. Next, please. 1957, essayist philosopher Lauren Isley said that, and I quote from him, that life may exist in yonder dark, but it will not wear the shape of man. But there are different takes to the statement, depending on which statement, which book or magazine you read. Some say the life would be vastly different. Some say there'll be small altercations compared to humanity here. And some even say that life would be so different you might not even be able to recognize it. It'll be staring at you right in the face. Next, please. Now, here's an image of Alan Tuff of the SETI Institute in Toronto. He's holding a nanotechnology-driven interstellar probe. It's the Earth type. This is not extraterrestrial of origin. And it just goes to show that it could be done cheaply, very economically. It could probably, it's cost-effective, and it's something that could be done with nanotechnology. In fact, it's been done right now today with the MOST telescope. Now, it's an enormous popular notion that ET is in our vicinity and waiting to establish contact with the humans. But the scientific community is not so optimistic about this idea. There is really no concrete or tangible evidence that of their existence here on Earth. However, there is strong circumstantial evidence, and that is the vastness of our universe, a compelling support that there's perhaps is life everywhere. Next, please. There's the Hubble Deep Field, and you could see all the galaxies. I think there's only one star in that picture with the spikes and the artifacts. Everything else is a galaxy, even the small grainy structure in the background. And, you know, who's to say that this is not possible? I mean, to say that we're alone, it's a kind of a sort of a narrow-minded idea. Now, in the universe, there's about 100 billion known galaxies. Next, please. And there's one of Albert's better pictures. That's M51. I'm just using that as a galaxy that harbors at least 200 billion stars. And using simple math, we can at least calculate that there's at least 10 billion trillion stars in the observable universe. Now, as far as modern star formation theories are concerned, at least some of those stars should have planets around them, orbiting them. And that they have found out that the planet-making process is relatively common. And in our cozy corner of the galaxy, there are well over 200 planets. Now, many of them, mind you, are of the hot Jupiter type. Of course, as we know, life cannot exist on those planets. But somewhere in between may lie the smaller terrestrial worlds or the rocky planets. Next, please. Now, is a nice illustration of a hypothetical civilized planet. Sometimes you wonder what do we mean by civilized, but in any case, the question remains, what percentage of planets will harbor life? And even taking it one step further, which will harbor intelligent life? Now, what do we mean by intelligent? Well, by definition, it is sentient beings capable of building societies, communication, and ultimately interstellar space travel. Now, for example, here on our planet, we're going back to a bit of biology here. Some plant species will produce billions of seeds. I'm using this as an analogy here, in the likelihood that one will grow to maturity. Now, can we apply the same analogy to other planets as far as life is concerned? Will there be a spark to start the process of biology on other worlds? Or are we the only paradise? Again, that is up to you. Given the right conditions and time, I believe life will take hold, develop, diversify, and evolve. Next, please. Now, we know that organic molecules, or carbon-based compounds, are scattered throughout the ISM, or the interstellar medium. Scientists have found complex organic molecules, next please, I guess, in ethyl alcohol, which is the drinking type, on the left, and on the right, formaldehyde, which is a type of preserving solution. Now, one thing we do know about the carbon molecule is that carbon has the ability to form large molecules. It is a versatile molecule. Now, life depends on the carbon atom's ability to combine with hydrogen, oxygen, and other atoms to yield an enormous variety of complex molecules. Now, due to the simple rules of covalent binding between carbon and other elements, a large number of compounds can be formed. As you can see, carbon is at the center. It sort of forms the basis of all this formation. But this still is not a guarantee that we will find life everywhere, perhaps in small pockets of the galaxy. Now, here on Earth, life is a product or byproduct of volcanic gases and organic chemicals delivered from comets and meteorites. Next, please. We know that early Earth was violent and dynamic, a planet that was plagued by at least 5 major mass extinctions. Of course, there were some smaller ones as well. Now, is this the same recipe that is mandatory for life to develop on other worlds? Will this scenario happen on other worlds in order for life to develop? That's a question where we still haven't found out. Now, volcanism and impacts common in early Earth history may have provided the environments needed to transform chemical compounds into living organisms or biological matter. Now, if life started here as soon as conditions allowed, then we can assume that life is common everywhere in the galaxy. Next question is, what is a life form? Well, entities that can be considered to be self-organized systems assembled by biomolecules. Next, please. Now, here's a simplified schematic of a paramecium or an amoeba, whatever, with carbon and water right there. And these are the factors responsible or that is conducive to the living organism. They have metabolism, they grow, they respond to stimuli, reproduce, and through natural selection adapt to their surroundings quite heartily. Next, please. Now, this is a cutaway image of a rock, but it's not the one from Greenland because I couldn't find it. The earliest circumstantial evidence is from metamorphosed sedimentary rocks along the western part of Greenland. And this one, not this one particular, but they age about 3.85 billion years, and that is using the carbon dating isotope data. And this was immediately after the great lunar cataclysm. Then taken at face value, life did start early. Now, as far as solar system research is concerned, from our robotic probes you've sent into space, we know more or less that there are no places for advanced life unless they're hidden and we can't find them. But right now, I don't think that's true. But microbial life may flourish beneath the Martian soil, deep within Europa's suspected saltwater ocean, and there's even a long shot possibility on Titan. Perhaps it's in deep freeze right now. Next one. Now, this was a very controversial image from the ALH meteorite, Allen Hills meteorite, found in south in the Antarctic. Now, there was another image I found, but I couldn't. It eluded me from the internet. There was a much better one showing a lot of these tube-like structures, just like a cascade. So I had to stick with this one here. Now, is this the case for early microbial life on Mars? Again, you're the judge on that. It's a strong circumstantial evidence image for past biological activity. This is what we have so far. Microscopic fossil remains from a meteorite, possibly from Mars, and composition similar to the Martian surface. That's why we think it's from Mars. Now, it's only one of about 32 such meteorites found in pristine condition in the Antarctic. This one landed on Earth about 13,000 years ago and was in space for several millions of years. And the life form may have existed on Mars several billion years ago. With this in mind, we then ask ourselves the question, will alien life be recognizable? Perhaps the evidence will be more subtle, such as in spectral lines of biochemicals found in another planet, or structures found in rocks from another planet that are not of obvious biological origin. Like I said before, it could be staring right at us right in the face, but we just might not know it. Therefore, the astrobiologists and biochemists will need a working definition of what life is and how to recognize it. Next, please. Here we have images of hyperthermophile on the left here, a couple of them, and black smokers or hypothermophile thermophile vents. This is actually where they live. They're niches, if they're homes, if you want to put it bluntly. Now, hyperthermophiles is a good example of perhaps life on Earth, but that can more or less be alien in some aspects because of its extreme, able to withstand extreme conditions on this planet. Now, they thrive in high pressure water that's about 242 degrees Fahrenheit. They live without light or oxygen, and they're found in and around these hydrothermal vents or black smokers on the ocean floor, and they are found at the bottom of the food chain. Now, unlike oxygen-breathing organisms and plants that use photosynthesis for energy, they get their source of fuel supplies by burning hydrogen with sulfur or carbon dioxide. A different type of metabolism is seen here within these organisms. And any living machine will find every opportunity to adapt to any alien environment. They are indeed quite hardy. They will diversify and evolve. Now, as a consequence of this reality on our planet, astrobiologists expect to find life elsewhere in the cosmos. Next, please. Now, the con factors, to close off, some of the con factors in other stellar systems that may prohibit life, such as a planet with a red dwarf. Red dwarf systems, they lack ultraviolet radiation for life to develop. Most of it is in the infrared life, which is insufficient. They flare violently in X-rays from time to time, and therefore they are not conducive for life in planetary atmospheres. But they last for billions of years on the planet orbiting a red dwarf, because this will give adequate time span for developing life. Red dwarfs have a lifespan of about 12, maybe 14 billion years, so there's enough time for life to develop. Next, please. Our Moon and Earth system. Our Moon stabilizes our planet's tilt axis, preventing chaotic shifts. This, of course, will induce wild temperature extremes. Now, other planets, will they need a planet, an object like the Moon, or will the life be able to develop on a planet without an object such as the Moon? Again, that's another question. Next, please. Our guardian planet, Jupiter, prevents asteroids and other debris from impacting Earth. Of course, when that happens, there is less of a chance for life to develop. Every time the solar system goes into the plane of the Milky Way, there is a greater chance of bombardment from objects from outer space. Next, please. In any spiral galaxy, again, another Sakeley image, our galactic orbit is circular, and of course this will keep the solar system stable and away from supernovae. Some scientists even speculate that stellar systems with radiation exposures as low as ours may be more than 100,000 times rarer. So we are indeed lucky to be in this part of our galaxy. Also, I don't have a picture of a globular, but you can more or less picture it yourself. We are not within a globular. Excessive radiation and gravitational disturbances from nearby stars will cause the planet-making process to be disrupted. So again, that's not good. Globulars are, of course, metal poor, and a star needs some metallicity in order to have planets. So if they're metal poor, there is no planets, and therefore there's just only stars. Now, being in the boonies means less stars and less planets, and the metals are less likely to be found in that area. And being in the burbs or the suburbs in the Orion Arm is ideal. So with that in mind, you could come to your own conclusion about what you think about these systems, the possibilities. Although I heard on the radio just a couple of weeks ago that there was a leakage on CNN. I don't know if any of you have heard about it. SETI has picked up something, but as soon as they aired it, they cut it off. And all we know is that it's a strong signal, it's intermittent, and scientists will take several years to decode it. And they're not saying anything more about it. So if you know of anything relating to that story, I'd be really happy to hear about it. And hopefully in a few months, I'll be able to talk about sending communications, communicating with other civilizations and the chances, and we'll see if I have time. So that's it.
Great. Okay. Thank you.
Watch the wires here.
How long is that?
Oh, no, we'll check.
Okay.
Thank you, Richard. Well, maybe the mysterious event was the end of the writer's strike. I don't know. All right. We're going to get on now to our turtle stories just before the break, something a little bit fun here. Remember we asked the question, why is there no turtle constellation? Here's the prize. Who's pictured up on the screen there? Here's the big prize. All right, who do we have up first? Al Seaman. I'm going to bring the lights up a bit here so we can... There's a lot of wires here.
Al, do you want to advance or just tell me?
Oh, yeah. How does this work?
Or just tell us.
Oh, okay, that's the... Okay, back in December, Brian collared me after the meeting and challenged me to really answer this question. Why is there no turtle constellation? Well, I allowed as how that might be an interesting bit of research. So I did a bit of looking into things, and I'd like to provide a report tonight. So anyway, the story starts a long time ago in a very distant land when King Acamar III was crowned. Now, his country was extremely small and was surrounded by many aggressive countries. King Acamar, as one of his first acts, decreed that they would now emulate the turtle. That is, build impenetrable walls around the major city and simply pull back behind the walls whenever threatened. This strategy worked admirably, and for many years the country enjoyed a safe and prosperous existence. To further recognize this success, the king renamed the country as Turtleopolis, and the turtle became a sacred symbol on flags and other official documents and buildings. As King Acamar was contemplating the skies one night, he decided that they needed a constellation that all Turtleopolis citizens could recognize as their sacred turtle. He summoned Mizar, his royal astronomer, and ordered him to find a turtle in the sky. Mizar worked diligently for many nights, searching for a little turtle. He finally found the perfect constellation. King Acamar was overjoyed. He said, "We shall call it Turtellini, the turtle." There was much rejoicing throughout Turtleopolis, and then one night, while viewing Turtellini, Acamar decided that it was now must be recognized throughout the known world, just to increase the status of their country. He ordered Mizar to make this happen. Mizar prepared a proposal for recognition of Turtellini and submitted it to the International Astronomical Union. Yes, that's right, the roots of the IAU go back many, many years, and their proceedings today are just as Byzantine as they were then. The proposal was debated at length in various subcommittees. It finally reached a plenary session of the IAU for a decision. Mizar spoke very eloquently on behalf of Turtellini and gained many supporters. Unfortunately, many others argued that since Turtellini was located in a sector of the sky already assigned to Draco the dragon, there was no room for Turtellini there. The debate raged for many days with no sign of consensus for either position. Finally, the chairman of the IAU concluded that further debate was pointless. He said, "The case is now clear. The turtle has been eaten by the dragon and no longer exists as a separate entity. There will be no constellation Turtellini." And so that is why there is no turtle in the sky to the present day. I take it there were no other challengers.
Step down, bud, but don't go far.
Oh, don't go far.
Who's next? Eve.
Well, first, I would like to start to say that contrary to Brian's belief, turtle constellations are not foreign to astronomy. Here are just few examples of turtle constellation in other culture and history. I'm not making this up. The end of my talk is not made up also, but is more to fantasy than to reality. So let's start with our first turtle constellation, please. Those three stars with the Chinese writing just beside it, right in the middle, is the Turtle Beak Mansion. Those three stars in Orion is one of the 28 mentions of the Chinese constellations. Astronomy in China has a very long history. The Shang dynasty, which is 2000 year BC, records eclipse and novae. Detailed records of astronomical observation were kept from about 600 BC until the introduction of Western astronomy and the telescope in the 60th century. Through careful observations, the ancient Chinese charted the heavens and compiled the earliest star catalogs. However, during the last century, the painstaking works of ancient Chinese astronomers have more or less sunk into oblivion. Next. This small asterism in the middle, circled, is Testudo. Testudo is Latin for turtle. This was a constellation located between the constellation of Cetus and Pisces, today constituting a natural but faint asterism composed from the stars 20, 27, 29, 30, and 33 Piscium pieces, where the star 20, next please, the star 20 in the far right, is indeed to be the head of the turtle. The origin of the constellation is uncertain, but it is alleged that it was created by an astronomer, William Henry Smith, in the 18th century. It is no longer recognized, but you would recognize it if you would see the next slide. Here it is. Next one, please. This is the turtle, the quail, the butterfly, and the twins. This group of constellations marked the beginning of the ancient Mesoamerican calendar count of 13 weekdays. The turtle is special to indigenous Americans on account of its ability to reach 100 years of age or greater. And since the calendar of much of Mesoamerican has a common run of 104 years, this is correlative. Also, the backs of turtles are known to have 13 spaces on them, and this corresponds to the number of days in a Mesoamerican week. In the middle of the turtle constellation can be found a quail head made up of the stars called Lepus. What appears to be coming out of the back of the turtle shell is a butterfly, which is called the maize god by Mayanists. There is a Meier rollout vase that shows this scene in detail, which can be found in many books or collection of Mayan artwork. I just came across it on the internet, but didn't get a picture for it. Sorry. What these scenes represent is the application of the knowledge of seasons and calendric to hunting and gathering, to make it agriculture and animal behavior science, the ingredients necessary to secure food stocks sufficient to sustain a civilization. Now, this is about historical and cultural facts. The following is about fantasy, which is based on culture. Let's go with the next one, please. Now, this is Great a Twin. I don't make that name up. This is the star turtle. I'm a big fan of Terry Pratchett's Discworld series of novels. So the Discworld is the fictional settings for all of Terry Pratchett's Discworld fantasy novel. It consists of a slightly convex disk, complete with edge of the world drop-off and consequent waterfall, as you can see, resting on the back of 4 huge elephants, which are in turn standing on the back of an enormous turtle. named Great Etwin, which is very similar to Chukwa or Acupara from Hindu mythology. Though world turtles are common to many disparate cosmologies. Now, Great Etwin is not fixed in sky like any constellation. No, it is flying through space. Great Etwin, who travels through space carrying the 4 giant elephants named Berelia, Tubal, Great Thorn, and Jerakeen, who in turn carry the Discworld and is introduced such as in nearly every book of Terry Pratchett. The narration has described Great Etwin, as the only turtle ever to feature on the Hertzsprung-Russell diagram.
So that's why we can't see it. It's beneath us.
Yeah, probably. Great Etwin gender is unknown, but is the subject of much speculation by some of the disk's finest scientists' minds. The sex of the world turtle is pivotal in providing or disproving a great number of conflicting theories about the destination of Great Etwin's journey through the cosmos. If, as the popular Big Bang theory states, Great Etwin is moving to his or her mating grounds, then at the point of mating might be the civilization of the disk to be crushed or simply slide off the back of the turtle. The other theory, described as being popular among academics, is the steady gate theory, is that he or she came from nowhere and is going to keep swimming through space to nowhere forever. Great Etwins attend the hatching of 8 baby turtles, each which 4 baby elephants and a tiny Discworld on their own, would seem to support the Big Bang hypothesis. A combination of the two theories might be possible, with Great Etwin being among the first generation made by the Creator and subsequent generation being created through breeding. That kind of support the creationist theory, would you say? Great Etwin has been mentioned to frequently roll on its belly to avoid asteroids and comet collision, or even to snatch these projectiles out of the sky, which might otherwise destroy the disk. So it could be that Great Etwin is at least conscious of the world, or maybe just doesn't not want to get bruised itself. These stunts do not affect the disk population other than to induce severe seasickness, or on anyone who happens to be looking at the night sky at the time. Due to Great Etwin traveling through the universe, the night sky of the Discworld, unlike that of our own world, changes markedly over the course of decades. As the turtle departs older constellations and enter new ones, this means that astrologers must constantly update and alter their horoscopes to incorporate all new zodiacs, which they don't do in our world. And to complete that, a tiny sun and moon orbit the Great Etwin. The moon is slightly closer to the disk than the sun and is covered one half with silvery glowing plants, which feeds lunar dragons. The other half is burnt black by the sun. The moon rotates and completes a full revolution in about a month. The full moon occurs when the luminescent side is completely visible from the disk. The new moon when the dark side is shown. The sun's orbit in a so complex way that one of the elephants has to cock its leg to allow the sun to continue its orbit. And that's all I'm going to say about Great Etwin right now. I could go on and on and on. I'm a big fan of that series. Thank you very much.
Great. Hey, yeah, and it's not tough to find what the gender of a turtle is. You just hold it up like this, and you can recognize right away that it is obviously a toy. All right, Eve, thank you very much for that. That's a beautiful background information on the mythology and stories of the turtle. I have to say, Al, could you come back up, please? Al Seaman? For a entirely created story. Come on up. I have to say, do we agree that Turtellini is the winner of the turtle? All right. All right.
Very good indeed. I do have a number of grandchildren who will be very happy to see Turtellini.
Roger that. Okay, good enough. Great, thank you. That's great, thank you. Chuck, am I up?
Okay, the question Iapetus, what was the connection between Iapetus and our planet? We have a winner, a genuine shatter cone from Presqu'île, the structure. I'll give you a story about it, just a quick story. Eric and I were at the Presqu'île crater in our canoe, in Eric's canoe, and we were going to a place where we knew there were shatter cones. A thunderstorm came through. We paddled like the dickens to get into the lee of this island. And here we were, you have to picture it. We're sitting under this tree. Boom, kabang, rain, rain, rain. And here we are talking about life, the universe, and everything. And Eric says, Chuck, there's a shatter cone over there. Ha, 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 ha. Laugh, laugh, laugh. Just kidding me. So I said, well, heck, I'm here. I'm going to get out. I got out of the canoe, and believe it or not, there was a pile of brand new virgin shatter cones from the Presqu'île. So the winner, next slide, is Al Scott. He guessed the Iapetus Ocean. Where's the, here we go. This was about 1.1 billion years ago. And just to give you an idea of the timing, the Sudbury impact was about 800 million years before this. And the Manicouagan structure is going to be about 800 million years after this, just to give you an idea of the timing here. Iapetus Ocean was 600 miles over 1,000 kilometers wide, and it lasted, a couple of 100 million years.
What are the other notations, Chuck?
The-
Tack, wave, sea.
I don't know.
Good answer.
Yeah, I'm not a professional geologist. I searched on the internet to find, this is the only image on the internet I could find.
It seems we've got me and a sound format and a Schmidt-Cass.
Baltica, well, these are obviously the Baltic areas, Greenland maybe, Nova Scotia, I don't know.
No, that's the SCT.
Okay, there you go. Anyway, congratulations, Al Scott.
All right, good.
Oh, I want to finish off one more. The family tree of Iapetus, just in case you all were wondering about, there it is. And Arthur C. Clarke, farewell. Thank you.
Thanks, Chuck. There's your pointer right there.
And Chris just does the slides, I guess? Yeah. Thanks, Brian. As many people know, a few years ago, I did a couple of talks on the geomagnetism and effects of the magnetosphere on radio waves, and that's why I'm interested in this subject, because lately there have been very few sunspots. So what I've been looking at, right now we're near solar minimum, and we've been like that for over a year now, about 14, 15 months by my count. So can we get the first slide, Chris? This is just to introduce what the sunspot cycle is. It's 11 years on average. The average year is 11.1 years for the last 23 cycles, but in fact it's varied between, the shortest one is 9 and the longest one recorded is 14 years. And as you can see from the first slide, that the number of solar flares also varies with the sunspot cycle. It's typically about 11 years. And right now, we're just nearing the end of cycle 23, and there's been some speculation on whether cycle 24 has actually started yet. There is a Canadian connection to this. This is the Penticton Radio Observatory at the Dominion Radio Astrophysical Observatory, where they monitor a proxy for sunspots using these are actually, they were surplus radar equipment from after the Second World War, and they found out by pointing at the sun that the microwave flux at that wavelength was correlated very well with sunspots. And not only that, they can do it during clouds also. So Canada has 61 years now, ever since 1946-47, of continuous data of this 10.7 centimeter flux, which correlates very well with the sunspot cycle. And it's Ken Tapping, in fact, who runs that, and he's a member of the Ottawa Centre, and I was corresponding about this just to find out what's going on, to see whether the 10 centimeter flux correlated or indicated that the next cycle was about to start. Next slide. There it is. I just took that. I took the raw data off of the internet from the NRC site, and then used an Excel spreadsheet just to plot it. And you can see it correlates. It's also an 11-year cycle. Next slide. And Ken's site provides a simple correlation where you can plot or correlate the 10.7 centimeter flux in solar flux units and then translate that to the sunspot number, which is the bottom curve. And you can see that both of them have a downward trend. The last point at the very far right on each of the graphs is March of 2008, and you can still, it's pretty low. It doesn't seem to be going up at this point. One thing about this is that, I'll show in the next slide, is that, I guess, well, not the next slide, okay, but the 10.7 centimeter flux doesn't distinguish between cycle 23 spots and cycle 24 spots. So this is a prediction. If you look at the bottom, this chart came out about a year ago, April 2007, and this is the NOAA is making this prediction of when and what the next cycle would be looking like. And they predicted that the cycle would be starting in March 2008, plus or minus 6 months. And as of this point, it looks like it's still going downwards. And the interesting thing is, if you look at the second, the predictions for cycle 24, there's two different sets of curves there. They had a panel of 12 scientists of experts, and they used two different models. And the panel came out almost evenly split on what cycle 24 would look like. And they're admittedly that space weather predictions are still in their infancy, and because the underlying solar physics is still not fully understood. But one model indicated that it would peak at about 140 sunspots count. The other one indicated that it would peak in about a year later at only about 90. And the current one that peaked around between 2000 and 2002 was about 120. And that was a fairly active one, too. There was a lot of auroras between 2000 and 2002. Slide. Now, this is a diagram of number of sunspots versus the position, their latitude versus time. It's called, obviously, it's called obvious reasons, it's called a butterfly diagram. And it's a graphical representation of what is known as Sporer's law. Sporer's law indicates is that the first sunspots of a given cycle start at around plus or minus 30 degrees solar latitude. As time progresses, they gradually migrate down towards the equator. It was found in the early 20th century that the polarity, the magnetic polarity of the spots in the northern and southern hemisphere were reversed. That if the North Pole spots were leading in the northern hemisphere, then South Pole spots would be leading in the southern hemisphere. You'll also notice at the beginning of cycle 20,
It's just the top.
Okay.
Yeah.
There is a bit of overlap. See that cycle 23 ended around here, but cycle 24 started about there, so there's, well, maybe better part of a year of overlap between the two of them. So that makes it a little bit interesting to see exactly how do you define where does the cycle start. Now, in January of this year, there was a couple of spots. In January 4th was one of them, and then about a week later, there was another couple of them that appeared to be cycle 24 spots, that they're at upper high latitude, and the polarity was reversed. And I believe it was within a day or two, the NOAA indicated that cycle 24 is now started. But interestingly, that there hasn't really been much in the way of activity since then. Next slide. Now, there's the spot. The way it's color-coded is that north polarity is white, south polarity is black. And the text that came with us on the space weather site said that that spot there was a reverse polarity. And now it doesn't look like it's a reverse polarity because it looks like south is leading in both cases. What they didn't explain, and I had to figure out, is that because, as I mentioned before, the spots on the southern hemisphere have a different polarity than the spots on the northern hemisphere, so these must be slightly below the equator, so that would be a southern hemisphere spot, that would be a northern hemisphere spot, and if they were the same cycle, they would be alternate polarities, and since they're not alternate polarities, that indicates that that was a reversed one compared to cycle 23, and it indicates it's a cycle 24 spot, and then there it is just in white light. And about a week later, there was another one. This one was an animation on the space weather site. Now, there it is right there. Now, you can see, in this case, this one is a bit ambiguous because It's not a high latitude spot like you would expect from cycle 24, and yet it is a reverse polarity. But it's so close to the equator, the solar equator, that it's hard to tell, I mean, which polarity or which hemisphere does it belong to. Anyways, on the basis of those two spots, they announced that cycle 24 had started. And it just a week ago today, in fact, NOAA came out and retracted that prediction because there's been really no activity since then. So next slide. So here's, these are spots that formed about the last week of March. All of them have the same polarity, and they're all equatorial. And they all have the polarity that indicates cycle 23. Next slide. Oh, can you jump ahead one more? Now, this prediction came out. This is a revised prediction for cycle 24. You can say you are here. See that little spike there? Those are the spots that formed at the end of March 2008. And it looks like now they're going well into 2008 before the predicted upturn. As for the actual prediction of what cycle 24 is going to be, they haven't come out with the actual prediction yet. What they've done is it looks like they've taken the peak of one prediction, which is 140, but the timing of the other prediction, which was 2012, which was the lower one, I don't think I'm not sure if they haven't come to consensus yet or whether they're still waiting for more data to predict which one of the two curves it's going to be. But it does indicate it, just like the smooth curve for the 10.7 centimeter flux indicates, likewise with the sunspots, that it does seem to be still on a downward trend. And as of this point, it's 11.75 years. So it is a little longer than a typical sunspot cycle, but still not beyond what could be considered the norm, because there was one that was 14 years. Just go back to the next. Now, why is this important? This is why NOAA is interested in this sort of thing. Solar activity does affect a number of things on Earth. Strong maximum means there's more solar particle events, which causes auroras, fortunately, I mean for us. But for negative things, for space weather, it causes a lot of damage or risk to satellites, communication satellites. It can cause the atmosphere to expand, which causes more drag, which decreases the life of a satellite. High particle fluxes also degrade photovoltaic cells that the satellites use for their power more quickly than expected. There was one incident that there was a satellite that was launched in the late 1980s, that its solar panels were rated for 10 years, and after one massive solar flux, it was degraded down to 5 years. So its lifetime effectively was cut in half. And then they're even talking about ionospheric disruptions will possibly affect GPS, but that remains to be seen, because I know that there is some compensation to compensate for densities in the ionosphere. Satellite losses, you may recall in 1994, the two Anik E satellites were knocked out of commission, and that was actually near solar minimum at that point. That was in around here. And yet there was a fairly powerful solar wind around that time that was highly charged with electrons, and what happened apparently was the satellites accumulated so much negative charge that it started disrupting the internal electronics, and then they lost control of the internal motors, the gyros that control the attitude, and that they weren't able to, they got partial recovery, but then they failed again. And then also, you remember in 1989, the Quebec power grid went down because of a large solar storm. So that's why it's important to try to predict these things and try to prepare for them. Okay, now, so it looks like the consensus is that, well, another thing that NOAA, when they came out with their prediction last week, they seem to have redefined how they're defining the beginning of cycle 24. Before it was the first spots that appeared. Now they're seeming to say that it's when cycle 24 spots, when their numbers exceed the numbers of cycle 23 spots. And we'll have to wait and see, because there have been very few cycle 24 spots at this point. So it could be another, it looks like we could be at minimum for another 6 to 8 months. But that just remains to be seen. Now, what really got me going on this is that I've got a Google news alert that alerts me to news events that involve Canadian astronomy and Canadian astronomers. And in February, I got this interesting National Post article. It showed in my mail. And at the end of it, well, first of all, it says Financial Post is actually a National Post. It says, "Forget global warming, welcome to the new ice age." And he's quoting Ken Tapping, and he's actually taking something that was written on the NRC website out of context and sort of exaggerating it. So I actually contacted Ken Tapping to see if he was aware of this. He was aware of it. Apparently, this started on some US blogs, and it's been sort of bouncing around, but he does say that he hasn't given any media interviews, and he hasn't been commenting on this sort of thing. But this sort of came out of the current fairly cold, long winter. And I think the Financial Post tends to be on the sort of the anti-Kyoto side of the debate. And they come out with things like this, and I wanted to see, is this actually true? Does solar activity actually affect weather like that? So I tried to do a bit of digging. Obviously, the sunspot cycle, which its activity varies peak to valley, maybe 3 or 4 to 1, doesn't affect the solar insolation by that amount, but I didn't know if it did affect it at all. So I had to do a little bit of research here, see what happens. Next one. This was what Ken was referring to in his NRC article. This Bonder minimum, there was a period of about 75 years when this solar cycle apparently, well, it actually shut down for 3/4 of a decade. And it just happens that coincides with the depth of what was called the Little Ice Age. Now, there's a lot of controversy here. If you look at that bottom sentence in particular, whether there is a causal connection between low sunspot activity and cold winters is the subject of ongoing debate. They don't say ongoing research, they say ongoing debate, because there basically is very little data that can be used to make correlations like this. I mean, it could be just a coincidence. In fact, there really is no known causal link between the two of them, because we don't really know what was going on with the sun. Whether its magnetic field actually contracted, or was it just the variation in the magnetic field that sort of shut down? And in fact, they're even expressing some doubt that possibly the Little Ice Age was confined to North America, which means that it could have been connected with the Gulf Stream. Something disrupted that. So anyways, it's hard to make any definite correlation here. That Ken's website, where he was talking about the quiet sun, mentions this, and he says, well, I'll breathe easier when the sunspot cycle 24 starts up again. But on the other hand, he's not too worried about it. He says we'd have to wait for a lull of maybe 6 or 7 years before it looks like it would shut down completely. In fact, he gave an interesting analogy. He said if you're standing out in the corner for a bus and the bus doesn't come, it's safer to assume that the bus is just late rather than to assume that the entire transport system is shut down. So anyways, he's not too worried about another Maunder minimum. And even if there was, there's no real proof that it was connected with a colder winter. Like we're not really sure why that is, and that seems to be the opinion of most scientists, that whether or not there actually was a cause and effect relationship between the sunspot cycle and the cooler weather. Finally, the last slide. This is a plot from 1978 of the solar constant, the solar irradiance, which is not quite 1,400 watts per square meter as measured at the top of the atmosphere. Now, it does follow the 11-year sunspot cycle, but if you look at that line towards the lower right, the variation on the smooth curve is only about 0.1%. I was actually interested. I thought the curve would go the other way. I thought with more sunspots, the solar constant would go down. It would actually get cooler. But in fact, the number of faculae, which are hot clouds, ionized plasma, go up, and they more than compensate for the number of sunspots. So there is a very slight variation there, but there doesn't seem to be a trend either. And there really is no conclusive or good data before 1978 is when the first solar satellites were put up there is some speculation. I've seen papers where they're using indirect measures to try to figure out what the sun or the solar constant might have been, say, back to 1900, and some of them are using sunspot data and various other things to hypothesize that there's actually an upward trend which correlates with solar warming. But from what I've seen, most of the credible scientific publications don't really think that that correlation is there. So occasionally you will see in things in the newspapers that suggest that the sun is warming and that's the cause of global warming rather than human activities, whether it's carbon dioxide or anything else. But it looks like from what I've seen and most other sites that I've been looking at that the correlation is very slight, if at all, that any variation of the sun is pretty slight, and it probably doesn't have much to do with the actual warming. So that's the last slide.
Good. Very good, thank you. Excellent. Thank you, John, that was excellent, thank you. All right, so we're on to our observations now. Just to close out our evening, and we've got, I think, Rolf, you're up first, please. That's your pointer button there.
Okay, good.
You want to advance the slides, Rolf? Or just tell me?
I'd like to tell you.
Yeah.
Okay, next slide. Okay, so this is about the Mars observations of, say, the last 6 months or so. And I presented a few lately, but I haven't been to the last few meetings because of snowstorms and whatnot. So over the months, observations have accumulated, so hopefully this is everything now. Now, I've talked before about the fact that there was a major dust storm in around June, and this created real problems in obscuring features visible on Mars. And the contrast was very poor until probably mid-September. And overall, the contrast gradually improved as the dust settled, and that took several months, and it's probably still not all out of the atmosphere yet. Lots of clouds were observed on Mars, and by clouds, that means water vapor clouds, and never observed as many clouds as at this opposition. And now, due to the dust storms that occurred in June, the albedo features, that is, the light and dark areas, they changed significantly compared to 2005, and I'll show you that comparison eventually due to this major dust event. And finally, I'm sure as you're mostly all aware, the last 3 to 4 to 5 months have had very poor observing conditions. Even on clear nights, the seeing was very poor, so it wasn't possible to get any really spectacular images, I would say, particularly with Mars being even smaller than it was at the previous opposition. And really, since the opposition, December 24th, there has been very little good observing for the planets because of the clouds and snow and everything else. Okay, so let's get into some of these images. So this was back in November 2nd, and what we see here is, I want to point out, this is the side of Mars where there's some volcanoes. This is Olympus Mons, which previously I showed as a very dark spot. And as the dust gradually settled, it got a little dimmer, but if you notice here, there's a little black spot right in the middle. And these spots here are additional volcanoes known as the Tharsis volcanoes. Now what happens, and you can see very faintly, is eventually clouds start to form over this region. At the bottom, what we often do is we show the black and white images, which are taken in red, green, and blue light. The red light shows the contrast of the features best, and the blue light shows the clouds best. So here you can see clouds and very bright cloud here. As a matter of fact, what you can do is you can quite often omit the green image, because the green is very close to being an average of the blue and the red. So what people sometimes do to save time and observations is to just eliminate the green, and for the green substitute an average of the red and the blue. Okay, next slide. And this is actually the picture that was in Sky News, probably one of the better pictures that I was able to get. And it now shows a lot of clouds in the North Polar Hood area, and we'll be seeing a little more of that as we go on. Next slide. This is the very major feature known as Syrtis Major, and this here is an area known as Hellas, and that we'll see later on has been quite altered. And you can see how bright it is in red light, and this is indicative of dust. And a lot of clouds again. Notice this red streak here, which is really just like a gap in the clouds and the features below. Next slide. Again, this is November 24th, a night of not too bad seeing. This is called Elysium. There's another volcano here, and this one is showing up as a light feature, probably due to some faint clouds. Now, there's another little cloud here, and lots of little clouds, as you can see in this area. Again, I should point out that the contrast here of all these features was relatively low compared to, say, the 2005 opposition. Next slide. This is known as Solus Lacus, the eye of Mars, and some faint clouds here. This is the south polar region, lots of clouds. No polar caps. The south polar cap kind of vanished in around the end of June, beginning of July. The polar cap was essentially gone, sublimated if you like. Somewhere underneath here is the north polar cap, but really what we're seeing here is clouds and clouds. Always on the sunrise terminator you see clouds quite often. Again, here there are the Tharsis volcanoes, no clouds over them yet. And again, this light area here is clouds, haze. Next slide. Almost the same circumstance. You can see a cloud here, cloudiness in this area, and a nice streak of clouds here. And in red light, even the clouds show up, but really well here in the blue light. Next slide. This was starting to get. This is I think very close to the night of closest approach, where Mars should have showed a lot of detail, but again the seeing was very poor. Clouds almost all the way around. Next slide. December 27th. This was very close to opposition, so essentially a full Mars. Clouds here and here. Donald Parker, who's a very famous Mars observer going back many years, he enjoys seeing the clouds. That's one of the main things he observes. At the bottom here we have all blue light images. Okay, and that shows the development of a cloud here, and then the dissipation of the cloud as the sun rises. Okay, the cloud kind of dissipates. So it starts to form. And over here, this is over the Hellas region, and it gets a little brighter, and then it dissipates as the sun rises. Next slide. And finally, this is January now. Very poor seeing, but again, what we see here now, Olympus Mons is practically gone as a dark feature, but just faintly visible are clouds over it, and of course, abundant clouds over the Tharsis volcanoes. Okay, next slide. This is a series of 5 images which show the rotation of Mars taken on a fairly good night. Taken maybe it's over the space of about an hour. Next slide. Okay, now this is very interesting. So what I found was there's an observer in the UK. His name is Damien Peach, and he takes some very excellent images of the planets, especially Mars. And what I discovered is I don't know whether I took a lot of images or whether he took a lot of images, but coincidentally, about a week apart, we took pictures of Mars at almost exactly the same central meridian facing the Earth. So as you can see, I was able to superimpose those, and we can start to see some differences. First of all, you'll notice that there's a slight phase difference, because at this time Mars was getting sort of in the waxing phase. So you can see mine shows that the phase has gotten a little bigger. Obviously cloud differences here. And what I was mostly trying to get was the changes in the north polar hood, okay, which is this area here. And you can really see the clouds, how they change the pattern and the different features visible below the clouds. But what I did notice, and a lot of research went into this by other people, if you notice here, there's one white area here, and I'll turn the laser off in a second. Just keep your eye on that white area, which you see remains stationary. So people looked up the location of this, and what people have concluded was that this is actually a crater, a large crater on Mars, and the crater bottom, and it's covered with frost. And it's believed actually this is the very first time that amateurs have taken a picture of a crater bottom on Mars with the frost on it, and have identified it. And there's a few other little white areas here that seem to stay stationary, but this here is pretty much identified as a crater bottom. And you can see some streaks of cloud here that changed. And next slide. Well, wouldn't you know it, the same thing happened a few weeks later. Damien Peach took a picture at almost exactly the same central meridian as I did, so I did the same thing. And again, you can see the difference in how the clouds have moved around here, and new clouds formed, even in the south polar areas. And this white spot here is again the Elysium Mons volcano. Next slide. Okay, so what I did eventually was compile all of the best images, put them into a program which takes the image information and converts it to a coordinate system and a map. So this is about a dozen images on top here that have been compiled together to form a map of Mars for 2007. Now on the bottom is what was done in 2005 using the same method. This was actually made by Damien Peach, and this is the one that I made this year. And so you can see obviously some big differences here. This is the Hellas region, which this year became very light, and in 2005 this feature here called Zeolacus was very dark and prominent. A new dark feature here, it's actually got a name, I forget what it is, and it's totally invisible here. Lots of other changes here around Solus Lacus. This area here being very light, and it was more or less darkish in 2005. This area here, lighter and darker. And this V-shaped area became very, very obvious in 2007. Now, this was taken when there was before clouds had formed over Olympus Mons, so it was a little dark spot. This was taken when there were lots of clouds over Olympus Mons and the Tharsis area. Remember, these are taken from images converted to a map. So this was kind of what I was aiming for. Okay, so once we do that, we take the map, and let's see again what it looks like as a sphere. So let's put that. So same program can take that and put it into motion. And that's it. Okay, that's it. Any questions out there?
Beautiful stuff, man.
Okay, this is actually just a few days ago, ISS. And you can see over the course of a few minutes, the orientation changes a little bit. And I sort of tried to enhance a couple of the images. It reminds me of a sailing ship, eh?
Yep.
Doesn't it look like a sailing ship?
Yep.
Ahoy, matey.
And
With
it's
the
weird.
turtle at the helm, right?
Yeah. So Yeah, I mean, it's weird. It really looks like a sailing ship. I don't know. It's absolutely brilliant now. This white, this is kind of the body of the ISS, but this white thing here, I mean, you look at pictures of it, and I think this is just a bunch of reflectors. I don't know enough about how this thing is put together. It looks like, a bunch of randomly put together mechano pieces, but, they've got...
You mean it isn't?
Yeah. So, I don't know, does anybody know why they have these kind of reflectors here? I guess maybe to keep it cool? I don't know.
Yeah, it's heat regulation.
So, because this is, and it's kind of, disturbing to get it's very difficult to get a good image because, this is kind of normal brightness, but these are brilliant. It's like mirrors. And these were all at the thousandths of a second, by the way, just to give you an idea. Okay, next slide. And Archimedes, just a crater, I guess. Maybe Brian wants to talk about
I do.
Archimedes.
I do.
You know that.
Thank you, Rolf. That was excellent. Thank you very much. All right, well, just while we have this nice image up, we doctored it a bit. Here's your lunar challenge. Here's your lunar challenge. Now, Rolf's shot of the of Archimedes here. This is Mare Imbrium. North is to the bottom, east is to the left. And this, so the Sea of Tranquility is down this way. Mare Crisium down this way. All right. Looking at Archimedes is a flooded, large flooded crater basin, 83 kilometers across. And if you're observing this, you'll see that you'll see some of these wrinkles coming along in Mare Imbrium, the lava flows. Look for the Spitzbergen Mountains, 1,500 meter peaks, right there. I've identified a couple of other craters there, including this this partially flooded one, spur. And there you see some of the rills here, the Rima Archimedes, the crater Autolycus. If you continue, this is what they call Palus Putridinus, the Marsh of Decay. And if you were to keep trekking on right to about here, that's where the Apollo 15 astronauts landed. And the picture that Gary Boyle had up in his observatory of astronaut James Irwin, he was on the Apollo 15 mission. So if you want to see where he was working, that's it over there. All right. So that's your challenge. This is the Isabel Williamson Lunar Challenge 78, and it's to observe Archimedes and the Montes Archimedes, all these Archimedes mountains to the south of the crater. All right, let's go to the next one, please. Hugo. There's your pointer there.
Okay. Obviously, this is not as serious as the last one. I just wanted to take a couple of pictures to show my friends, to send them on the internet to prove that I saw the eclipse. And but there are about three, I think, significant points in taking these pictures. The